Dear students, in this video we are going to learn about the concept of hierarchical clustering and density-based clustering in machine learning. Hierarchical clustering is an unsupervised machine learning algorithm. It deals with the unlabeled data. So it partitions the data into different clusters. The data needs to be partitioned into different groups at different levels in the hierarchy. This hierarchy looks like a tree structure. In a machine learning problem of organizing the employees in an university having different departments, first the employees are grouped under the different departments in the university, and then within each department the employees are categorized into the roles such as professors, assistant professors, supervisors, lab assistants, etc. This creates a hierarchy structure of the employee data that eases the visualization and analysis of the employees in the university. So generally hierarchical clustering is applicable to the data which is having the underlying hierarchy structure in it. By using this hierarchical structuring method, we can discover the underlying hierarchy in the data set. So the clustering methods are categorized into hierarchical clustering and partitioned clustering. So in the previous video we have seen the partitioned clustering method. In the current video we are going to look into the details of the hierarchical clustering. Hierarchical clustering is further classified into agglomerative clustering and divisive clustering algorithms. Agglomerative clustering. It is a bottom-up clustering technique which starts with the individual objects in the data as clusters and then iteratively merges them into to form large clusters. The second method is divisive clustering. It is a top-down method. It starts with one cluster with all the objects in it and then splits it iteratively to form smaller clusters. So these are the two different methods of hierarchical clustering techniques. So let us see the visual representation of agglomerative clustering. In agglomerative clustering, it is a bottom-up approach. It starts with each as a single cluster, and then see here A, B are the single objects in the cluster, C, D also single elements in the cluster, E also in a single cluster. Then it will merge these clusters according to their similarity into the next cluster in the next level. CD is merged into another cluster group. E is merged into the cluster group of C, D and E. Finally, all the smaller clusters will become the larger cluster. Agglomerative hierarchy clustering uses the bottom-up strategy. It starts with each object forming its own cluster, iteratively merges the clusters according to their similarity to form the large clusters. It terminates either a certain clustering condition is imposed by the user is achieved or all the clusters merge into a single cluster. So according to similarity, small clusters will be merged into larger clusters, and this process will be repeated iteratively until certain user-defined condition is met or all the clusters are merged into a single cluster. So see one more example of agglomerative clustering. Here there are alphabets, special characters and numbers as the elements in the leaf nodes, and based on the type of the element, A, B are merged into one single cluster, 1, 2 are merged into another cluster, and special symbol star is merged into become one cluster in the next level. And this process again will continue in the next level in the hierarchy. AB continues to the root cluster, and this special character and 1, 2 they are merged into another cluster. Finally, AB star 1, 2 they are merged into a single cluster. So here the main objective is grouping the elements in a text into numbers, special characters and alphabets. Next one is a divisive clustering technique. It is a top-down strategy. It will start with the largest cluster with all the objects in it. Then it uses recursive technique to form the smaller and smaller clusters and forming the hierarchical structure. The end of the iterations is achieved when all the objects in the final cluster are sufficiently homogeneous, or the final cluster contains only one object in it, or there is a user-defined clustering condition is achieved. Then the iterations are terminated in this divisive hierarchical clustering. Let us take up this example. In divisive clustering method, the algorithm starts with all the elements in the single cluster, and based on the relation between the objects within the cluster, it is dividing into two categories. One is alphabets into one cluster, non-alphabets into another cluster. Then again, based on the similarities of the objects within the cluster, the star is divided into a different cluster group. 1, 2 is divided into a different cluster group. Then finally, when we look into the leaf node contents, all the alphabets are belonging to a same cluster group. Special characters are belonging to the same cluster group. Numbers are belonging to the same cluster group. So in that way, the homogeneous objects will be falling into the same cluster group. This is divisive clustering method. So in both the agglomerative clustering and divisive clustering method, the selection of the split or merge is important, because the subsequent splits or merges depends on the previous ones. So we do not have any option further to rectify this decision if there is any mistake is done in the split or merge in the previous step. This will result in the poor clustering quality at the end of the iterations. Dendrogram. Dendrogram is a tree representation of this hierarchical clustering process. So at level 0, all the leaf nodes will be there. Level 1, some kind of grouping is done. Level 2, another kind of grouping is done. Level 3, next level of grouping is done. Like that, this process will continue in the either in the top down to bottom or bottom to top elements in the given data set. So this dendrogram is commonly used as tree structure representation of the step-by-step creation of the hierarchical clustering. It shows how the clusters are merged or split into different levels in order to arrive at the optimal clustering solution. And it also visually demonstrates how this merging or splitting at each level is arrived at the hierarchical clustering. Proximity measures. What are the proximities used for measuring the efficiency of the clusters? There are 4 standard methods are used to measure the cluster's efficiency. This cluster efficiency is measured by using the distance between the clusters. Let us assume that Ci and Cj are 2 clusters, and Pi are the points representing the cluster Ci. Pj is a point representing the cluster. Ni and Nj are the number of points in the cluster Ci and Cj respectively. So we want to find the mean of the clusters as Mi. The objective of minimum distance is to find out the closest points Pi and Pj, where Pi is belonging to Ci and Pj is belonging to Cj. Consider this is Pi, this is Pi, this is Pj. They are nothing but the points in cluster Pi, Ci and Cj. These 2 points are having the minimum distance compared to remaining points in the clusters Ci and Cj. So this is minimum distance points in the clusters. Maximum distance points in the cluster is nothing but farthest points from the 2 clusters. So this is Pi, in Ci, this is Pj in Cj. The distance between this Pi and Pj is maximum compared to any other pair of points in the two clusters Ci and Cj. So this is maximum distance points in the cluster. Mean distance d mean is nothing but the difference between the mean value of the cluster Ci and cluster Cj. Average distance d average Ci Cj is equal to sum of the distances between each point in Ci with every other point in Cj divided by total number of points in Ci and total number of points in Cj. When to terminate the clustering algorithm? Often the distance is used to decide when to terminate the clustering algorithm. In agglomerative clustering, the merging iterations may be stopped once the minimum distance between two neighboring clusters becomes less than the user-defined threshold. For example, this is the minimum distance identified between the two clusters based on the minimum distance points in both the clusters. If this minimum distance is less than some threshold value, user-defined threshold value, then we can stop the clustering process, because when you reduce the difference, all the non-homogeneous points will be clubbed into the same cluster. Using the minimum distance between two neighboring clusters becomes less than the user-defined threshold, then the agglomerative clustering will stop the iterations for merging. If the algorithm uses the minimum distance d minimum to measure the difference between the distance of two clusters, then it is referred as nearest neighbor clustering algorithm. If the decision to stop the algorithm based on the user-defined limit d minimum, then it is called as single linkage algorithm. So that means the d minimum is used for measuring the distance between the clusters, then it is called as nearest neighbor clustering algorithm. And the decision to stop the algorithm further based on d minimum, then it is called a single linkage algorithm. Similarly, if the maximum distance is used to measure the distance between the clusters, then it is referred as furthest neighboring clustering algorithm. Example, the maximum distance Pi and Pj are having the maximum distance here. Then if this maximum is used for measuring the distance between the clusters, then it is called as furthest neighbor clustering algorithm. If the decision to stop the algorithm is based on the d maximum, then it is called as complete linkage algorithm. So if it is d minimum, it is called as single linkage algorithm. If it is d maximum, it is called as complete linkage algorithm. So generally, this minimum and maximum measures provide two extreme options to measure the distance between the clusters. They are prone to outliers and noisy data. So therefore, instead of using this minimum and maximum measures, if we use the mean and average distance, it will help avoiding these outliers and noisy data problem and provides more accurate results. The next method of clustering is density based clustering method. It is also called as DBSCAN clustering. So generally in hierarchical clustering, the results of the clusters are either spherical or nearly spherical in shape. Example, this is spherical or nearly spherical shape. That is hierarchical based clustering technique. Suppose if the clusters are shaped like S-shaped or uneven shaped clusters, then this hierarchical shaped clustering will not provide accurate results. Therefore, we go for density based clustering techniques to provide solution for arbitrary shape clusterings. Example, see, this is one type of arbitrary shape cluster. This is another arbitrary shape cluster in the given data set. This is also another arbitrary data set. Here, these are all density areas. These are sparse areas. That means less density of points in this area, more density of points here. So like that, this is also one cluster with this shape. This is another cluster with this shape. Like that, we have various forms of clusters. This type of clustering is not suitable for agglomerative clustering or divisive clustering. So we use density-based clustering. The principle behind this density-based clustering is it will identify the dense areas and sparse areas within the data set, and then it will apply the clustering algorithm. DBSCAN is one of the popular density-based clustering algorithm. It creates the clusters by using the connected regions with high density. So that means it uses the density of the points in the data set in order to identify the clusters. So this is another density. This is also another density-based clustering data set. Here the data sets are more denser here. So like that, this is another S shape. This is some kind of arbitrary shape. This is some kind of arbitrary shape. This is some kind of arbitrary shape. So if this type of arbitrary shapes are there in the data sets, then it is better to go for the density-based clustering technique than hierarchical-based clustering. So therefore, whether to choose the density-based clustering or hierarchical-based clustering technique, the user must have some kind of idea behind the type of the data present in the data set, so that he can choose the right algorithm for performing the clustering in the unsupervised learning in machine learning algorithms. Thank you for watching this video.